Okay, we left off with this conundrum, and the problem, really the heart of the problem, was that there is no size indication in either the source or destination operation. So when the machine goes to try to execute this, it says, okay, I know that I'm going to add 20 to what EBX is pointing at, but here's where I can use another directive. Do you see what we've added here? Byte pointer. Now this instruction, if you were to read it in English, reads add 20 to the byte that EBX is pointing at. So I'm going to add 20 or 1-4 to this to get an answer that overwrites. Okay? In the same way, I can use word pointer, I can use double word pointer, quad word pointer. This next example we're also going to do in class. Here's where we're first going to start looking at input and output. So for this chapter we actually look at two different frameworks that we're going to use. We'll use the first one, Console 32, briefly. The rest of the time until we get to chapter 5 or 6 we'll be using the Windows 32 console, not Console 32, Windows 32. So we'll work on this in class. This will be fun. While we're thinking about that, though, let's talk about input and output. A high-level language usually provides a way to accept a string of character codes representing a number, then converts the characters to their two-complement numeric equivalent and stores that numeric value in memory or in a register. So the operating system doesn't do this. The language has to have routines built in. So in assembly language, we must also code these routines. There is a file that we'll see when we start looking at all of our stuff, io.h. Now, you guys in C++, you did something like number include IOStream, okay? And that gave you access to cin, cout, the insertion operator, the extraction operator. All of those are objects defined in IOStream, okay, in the same way. So C++ did it, you didn't even have to think about it. In the same way, when we're doing all assembly language, we're going to have to figure out how to do that. What we have is io.h, io.asm. io.h is a header file, hence the .h. So think about this in the same way that you would a header file in C++. This is where prototypes are stored, and then the implementation file is where the definitions are stored. Later on, we'll actually look at some of these input-output macros, look at the io.h and io.asm. Once we've gone through a few more instructions, though. Okay, so let me talk about some of the macros that are included in io.h. The first one is A to D, ASCII to double. A to D scans the string starting at source for positive or negative, followed by digits, interpreting these characters as an integer. The corresponding two's complement value is placed in EAX. So EAX is the default destination. Okay. Input error occurs if the number has no digits or is out of range. But this is a way, so remember, you're typing a character at the keyboard and you type 15 and then you hit the enter key. The A to D macro is going to go read those keystrokes where you stored them in memory, take them, convert them to numeric, and then store that in EAX. Okay? Very, very handy. Let's look at D to A. This goes the other way. So let's say I'm in a loop, I'm calculating a sum, and then once I have the sum, I calculate an average, and I want to store that average. Well, remember, I'm always storing, thinking about output to the screen. And in this case, I've got to take these numeric values. Let's say my average is 92.5. When I store 92.5, it's going to store it as a floating point number, but if I output that, I'm going to get a whole bunch of junk. What I need for the machine to do, and in this case, what I need for this macro to do, is take the double word at source, and that can be a register or memory, and convert it to a string of ASCII characters located at destination. Now, a couple things here. So, once again, let's say we have 103. So 103 numeric is going to be, I need it to convert this to 313033 hex, which is 103 when we look at it. Okay? Now, here's the tricky thing. Since this is double to ASCII, it's going to read the source, convert it to a series of ASCII characters. The length of this string is 11 bytes. So my big question is why? Why 11? So I'll come back in class and we'll talk more about that. Or maybe see if anybody has an answer. All right, next one. A to W, A to W, A to D, A to W, ASCII to word. So this macro, ASCII to integer or word size, scans the string starting at source for a positive or negative sign followed by digits, interpreting the characters as a 16-bit integer. The corresponding 2's complement value is placed in AX. So AX is our default destination, just as in A to D, EAX was. Okay? Again, input errors are going to occur if the number has no digits or is out of range. Now, let's look at W to A. In the same way D to A work, W to A is going to take a word, a numeric 16-bit numeric value, and convert it to ASCII characters. So the word is located at the place in memory associated with the identifier source, whatever you call it. And that again can be register or memory. Converts it to characters and stores it in destination. Now, for W to A, when it stores it, it has a certain size. How many characters? Let's just say it that way. Needed to store the range of 16-bit values. As ASCII characters. Okay, again, we'll talk more about that. Class, chance for some great answers. All right, so all of these were conversion macros. Let's talk about input. This one I showed you as an example. The input macro generates a dialog box with a label specified by prompt. So whatever you indicate here, and prompt is usually a place in memory that has a series of bytes allocated with a message indicated. So it's going to generate a dialog box with the label specified by prompt, where prompt refers to a string in the data segment. When OK is pressed, or enter is pressed, up to length, number of characters are copied from the dialog box to the memory in destination. Okay? All right. You know what? I'm gonna make a note here. What happens? In other words, what gets stored at destination when we hit enter? Ooh, more questions. All right. All right, there was input, here's output. Output has two arguments. Output is a macro that generates a message box with the label message, and the value message is in the message area. So if you're looking at, it's just like a GUI window, okay, where you have, this is my label area, this is my value area, okay. Each of label and value refer to a string in the data segment that we've already defined and stored values in. So that's it. We are done with Chapter 3. I'll see you guys next week.